Welcome to the lesson on logarithmic differentiation. So you might read that title and say, oh, alright, I already know how to do this, right? I know that the derivative of ln x is 1 over x, and I know the derivative of log base any log base b of x, right? And that's true, that's good if you know that. So you know the rule for taking the derivative of logs. That's not quite what we mean when we say logarithmic differentiation. What logarithmic differentiation is a technique for differentiating a very specific type of function rather than just a rule for the derivative of logs. So the type of function that logarithmic differentiation is going to help us with is something like this. Y equals x to the power of x. So, if you look at this function, and you say to yourself, okay, I want to take the derivative of this, how am I going to do that? Well, you might think power rule, but power rule only applies when the exponent is constant. You might think exponential rule, that only applies when the base is constant. So, in this case, we have a variable in both the base and the exponent. So we can't use power rule or exponential rule. So we're going to have to do something else. So the problem really is the fact that, there's this x up in the exponent. We don't like that. So if we could get rid of that x from the exponent, the variable from the exponent, that would be nice. What techniques do we have for getting rid of a variable from an exponent? Well, the title might suggest something. We have a log law, or a ln law, which allows us to, if this was a ln, take that exponent down. So that's what we're going to do. We're going to take the log of this. But of course, if we do it to this side, we got to do it to this side. Now, which log? I think I kind of gave it away there. Which log should we take for both sides? But we know that if we're going to do the derivative, the easiest one to do the derivative of is ln. So that's what we'll do. We'll take the ln of both sides, and then we'll apply that rule where we can take the x down. Okay, so now we've dealt with that issue. Now we can take if we look at this, we can take the derivative of both sides, because we know how to do the derivative of all this stuff. So d by dx on both sides. So what's the derivative of ln y with respect to x? Just 1 over y. dy dx. And what's the derivative of x? Ln x with respect to x. Product rule. So it's the product rule. So derivative of the first times leave the second plus leave the first times the derivative of second. Just one comment about this right here. I kind of glossed over it. Remember, we were taking the derivative of ln y with respect to x, so derivative of ln y, 1 over y, but these variables are different, so that's why we have to do implicit differentiation. Put the dy dx there. Remember, it's like chain rule. Now, we want to get the dy dx by itself, so we don't like this 1 over y, so what we'll do is multiply everything by y, and then just simplify the rest a little bit. Plus x times 1 over x is just 1. Now looking here, y times ln x plus 1. Notice we have x and y in this answer. Really, we just like x. So we're going to change y to x to the x, because y is equal to x to the x. And that way, we'll just have x's in our answer. Okay. So that's the derivative of x to the x. And that's example of using logarithmic differentiation. So that's a pretty simple example. That's like your most basic example. It can get a little bit trickier, but same basic technique. So let's take something like that, to the power of ln x. So we want to take the derivative of both sides. Can't do it now because we don't have a rule for this, but same problem, that there's a variable in the exponent. What am I doing? So how do I do that? How do I get rid of the variable from the exponent? Same deal. Ln both sides. And now the variable can come down. So now we have a bunch of stuff that we can take the derivative of. So we'll differentiate both sides. Just to save a line, throw my d by dx's up here. So derivative of ln y is 1 over y, x and y, different variables, implicit, it's dy by dx. And we got a product rule again. So derivative of the first times the second plus, what was my first, ln x times derivative of the second. So we got a bit of a chain rule going on here. So let's derive the inside, and now the same thing, we just want dy by dx by itself. So we'll multiply by y. And again, clean this up a bit. Ln x all over x squared minus 1, and just change that x, or sorry, y, back to what it's equal to in terms of x. So the original function y was equal to x squared minus 1 ln x. Now in this bracket here, you might want to clean it up a bit. Like, you can get common denominators if you really want. I'm not going to bother to do that. I don't think it's going to help much. And really, who's got that kind of time? And for a test or whatever, this would be far enough. You don't have to simplify that down any further. Okay, so this example is another example of logarithmic differentiation, and hopefully you see where you're going to be using this technique. Right? Basically, anytime you have an exponent in the, a variable in the base and the exponent, you got to get the variable out of the exponent. So you'll take ln, or use this technique.